Welcome to the public AI-Café. Today, our speaker is Mahmoud AbdelAziz. He's the founder and CEO at DevisionX, and he will present his talk, The Effect of No-Code, Low-Code AutoML Solutions on the AI computer vision industry. So first I want to say hello, Mahmoud. Great you're here.
Yes,
hello.
Yeah.
And hi, Emma.
Hi.
Also, so Emma and me, I'm Carmen. We are the moderators of this AI Café, and we also organize it. So if you have questions, you can always send us an email. And what is this cafe about? The cafe is about to get insights into the European, but also international AI scene. Participants get the chance to share knowledge and experiences and meet stakeholders from various areas of AI research and application. There's also rules in this cafe. Please take notice that the session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for Media project opinion. So welcome for also the audience we cannot see. We only know you are there. Great you're here today. And this is interactive, so means like we really want your questions after the talk of the speaker. Send us questions. This is the fun of the whole live show, that we get surprising questions. Whatever you like, send it per text to us. There is like a control panel, a menu on your screen, which is from the software, and there you can send questions in the chat. So use it whenever you comes up something you want to know. We're gonna read it afterwards to the speaker. So now we time to introduce our speaker. Mahmoud AbdelAziz has 10 years of experience in various fields, including machine vision, robotics, artificial intelligence, digital transformation, Fintech, e-KYC, RPA, and SaaS. As the founder of DevisionX, Mahmoud is leading the company to disrupt the AI computer vision industry by building a no-code AutoML SaaS tool called Tuba. He possesses a unique skill set that combines technical product knowledge with a deep understanding of business needs. So this is very wonderful that you're here, especially that you are an entrepreneur, which makes our cafe more rich, because we have a lot of people from universities, a lot of people from research projects, but very exciting are, of course, the entrepreneurs who are trying to find customers and really trying to make money with this. So we are looking forward for your speech. I give now the moderator role to you, Mahmoud. Then you can slowly start your presentation. Now I made you the moderator and we are looking forward.
Okay, perfect. So you see my screen now?
No.
You don't see it.
We try once more. We don't see, so
it's appear now.
We give you once more, one more. Maybe something went wrong.
I can see the screen.
You can see it? Good. Then it's good.
You see it?
Perfect.
Yes.
Okay, perfect. So thanks, Carmen, for the introduction, and thanks for everyone attending this webinar. So again, my name is Mahmoud AbdelAziz. I am founder and CEO at DevisionX, and I will start from this agenda. So we will talk today about more insights about the AI in computer vision industry as a market insights, and also advantage and limitation of this industry. We'll have some discussion about the new players in the scene today, but from the AutoML part, no-code part, how to involve with the human in the loop, and all of that, how it's changed a different approach or implementation of AI computer vision in the industrial sector in general, and also we'll show some examples of open source tools and also online tools to build your AI computer vision models or solutions. And at the end of this presentation, you will know why we will have a new market growth for this industry. And I will start from here about the insights. So today, or in 2023, we have about $17.2 billion about the market size of AI computer vision, or AI in the computer vision market itself, expected to increase to reach $45.7 billion by 2028. So we will see now why we have this big growth, what will happen happening in this industry as a proof of this growth. So I will start off from the basic first about the adding AI component to the computer vision. We know that computer vision as an application or science, it's old one, not new, but adding AI to it, it's just updated in last 10 years. So it is enabled to build a system by learning through data instead of make a sequence or systematic program. And this changes the way we develop computer vision applications than before. That leads to different advantages and limitations. So we also some advantages here that building AI computer vision make it more adaptable with different applications and also learning. So you always learning from the changes and from different products or objects. So it is not a static product. It's fit with complex cases that can be solved before, and also it's best for big data. Yes, we have some limitations too. It's data dependency. So if you don't have the data or have a small slice of it, so it will affect the system performance. Sure, it needs high computing power, but thanks to NVIDIA or GPU's power now that enable us to build a powerful products depending on this type of technology, moving straight forward with the hardware development, and also about transparency, especially if we are talking about sensitive cases in medical or financial sector or other sectors too. So it can, we don't, in some cases, we don't know how the model is works, so we have some lack in this area. But all this limitation, for sure, we don't have a perfect system, but as advantage make us more adaptable and more biased to work in this area of AI computer vision. So we started as a computer vision only, then it's updated to AI in computer vision. Then now we have a new player in this. We have the AutoML or automation of machine learning. Okay, so I will take this funny example. Now, if you want to make a cake, so you have two options. An easy, quick option to just buy this this package from the supermarket and just put it in the oven. So it will be just quick and ready within 10 minutes or more, something like that, without any details to make it. And another solution is to take the whole ingredients, all this in the photos, egg and the butter and the oils and the honey and all of that, and try to go to a steps on the recipe and then put it in the oven. This is a very simple example of what is happening now using AutoML. So you have two options here. So you can use the traditional machine learning training workflow. So you will define the problem and collect the data, make some processing of this data, make a training model, make some changes in the models itself to have the best model for it. So you can make evaluation and then iterate the same cycle again and again and again. So it is a long cycle. It takes a lot of information and a lot of experience and a lot of time to make it. And you have another option based on AutoML tools. So you just will define the problem and collect the data and feed it to the AutoML engine. And after that, you will make evaluation to the output model, and you can repeat the iteration again and again. So you have here an straightforward process using AutoML, and here you have a start from scratch to build everything from scratch and then make your evaluation and have this iteration again and again. Plus the AutoML part, also we have a second new layer in the scene. So to have the no-code and the low-code concept. So to just make a differentiation between them, no-code, you just have you as a user, you can make everything through graphical user interfaces or something like drag and drop or plug and play. All these terms refer to the no-code term. So you don't need to have to be a programmer or a coder to make this. So just working with interfaces in the no code. For the no code, yes, you work with codes, or you can make some functions through the command lines, but you don't have to go to the details. So just something like high level coding, and this is the low code. So we have two different concepts, but the two concepts are leading to one thing, that how to simplify using of this tool. So by merging this type of methodology of no code and low code with the AutoML, we have everything is straightforward and ready to be used by the normal person or the non-coder or non-expert person. And this is the area or how it works. So this is the pipeline. You have the data or images in our case, and this input. You have two examples. You can use the normal or traditional one from data exploration, preparation, and feature engineering, and the model selection, and all the stuff to generate your model at the end. And you can use the enabling tools, no-code AutoML tool as example, to just generate your model and make the prediction, and also make the integration or the deployment for it. And then we also add the third one player in this pipeline. So the third one is adding human in the loop. So we have now the AutoML part, the no-code part, the domain expert now. So we have data, we have learning or building a model learning from this data, and also we have as a domain expert. The role of domain expert is to make sure that this model, or we can call it brain, learned correctly from this data, and also this data are correct and related to the case that he or she trying to solve. And by adding the domain expert in the loop, we accelerated the development itself of different models and in different fields, and also increases the AI computer vision application accessibility to our audience. So now we have a different type of users and the builder, so they can know this technology, and yes, we can use this to solve our problem in this factory or in this facility. So now we have a different view of problem solving and implementation too. So all of that together leading to this type of benefits. Yes, when we develop tools or AI computer vision applications building on this type of AutoML plus no-code plus domain expert, so for sure we reduce time and the cost of implementation. So if you are SMEs or startups, so you need to have a full computer vision team to build a solution. So we can at least add have one. And for sure, you know, the war now between companies about hiring the AI talents, big companies and also small companies too. So adding these tools in the middle between this war, so it will make it possible and easy to build this type of solutions. So yes, we reduce time and the cost. Also, as it become easy to implement and develop this type of solution, so it's open a new opportunities to build many solutions for many problems. So the vision now are bigger, and so you can have a new problems can be solved with a new solution based on this type of technology. Also, you know that the machine learning process are experimental process. So now we need to have a quick iterations or a quick experiments. And when we use this type of tools, we accelerate this experiment. So we accelerate the whole implementation process and time. The last thing is about democratizing AI itself. So it's a good chance to identify the analysis between biases and also for algorithms. So we need to check if these models are biasing or not, have some errors or detection errors as example or not. So this type can be solved if you have also the domain expert to evaluate from his point of view. This is one. And second one is about democratizing the AI itself to enable people to build their AI models by themselves, not to depend on a ready-made model. So it is a two totally different approaches. So now the scene is about AI computer vision plus AutoML plus no-code plus domain expert. So adding all of these components together, for sure, it will change the way we implement this type of technology and the way we how we thinking about the problem itself. And also, it's open something like a horizon to have many and many new applications implemented these. So to make it real for you, actually it's happening today. It's not in the future. It's happening today. How it changes the industries in the way of implementing this type of solutions. So I will just show you different examples from different industries. So now, if I'm working on the manufacturing sector, in each manufacturing sector with different, it can be food and beverage, pharmaceutical, metals, automotive, and the other and many industries from manufacturing sector. All of them have the same type of quality inspection or machine vision based quality inspection systems at the end of their production lines to make the quality inspection more automatic. These systems are old, it's not new, so they are installed in this production lines to automate the quality inspection process. But the idea here is not in the system itself. The idea is how to implement it. So we, in our case right now, we enable the quality engineer or the production engineer or the maintenance engineer to build the system by themselves, not to depend on other provider or other companies to build it for them. So they just use the platforms and they generate their models based on their data, and for sure they own their model as they own their data. So we have here something about the IP itself of these models. So we have totally different approach, and in one factory. So if you have access on this type of platforms or tools, so the non-AI expert but they are expert in their field. So they are, for example, if you have something like a factory of pizza or something like that, so you will have a food expert. So this food expert will use the tool to generate the quality inspection models and put it on the camera or on the edge and or different signs of implementation. So it's totally different in this area. Also, if you are building industrial robot, something like that, and he need to be a VGR or what we call a vision guided robot. So adding the vision component to the robot, it make it more smarter than before, and it can make the operation more easy. So in the same case, the industrial engineer or the robotics engineer can use this type of tools to build this vision model to work and integrate it with the robot system, instead of also building it through another provider or building it from scratch. So make it easy to add some component to make the operation more easier, and for sure it will accelerate the whole business process. Also, we'll have something here about the workers and the machine monitoring. So this common application is more common in the sites like construction sites, oil and gas sites, energy also sites, and any sites that have a lot of human workers and also machines working together. So here you need to monitor the machines, the cars, the trucks, the people, the safety regulation, and many other regulation also that should be followed in this type of sites. And each site has its customization for this, and for sure also you enable organizations to build their models customized for their cases, so they can make also we can call it a feedback loop. So just make it and put it on the cameras or on the deployment system, and then they can improve and have version 1 and version 2 and version 3 from this type of models. So it's changed also the area of implementation in this type of application. Another application also related to the logistics industry, and we have also booming, especially after the COVID-19 in 2020, booming in the e-commerce and retailers industry, and all of them need to automate their warehouses and automate also the purchasing process too. And the part of this automation is to have a computer vision applications behind the cameras that already installed in these warehouses to monitor the movement inside warehouses and the boxes, products, and everything there. And to also to have this type as a customs also model, so you need to have a platform to develop it, and also to make it easy for them to develop these types of models and this type of monitoring for their warehouses. So it's also the implementation approach is different through this type of tools. The same also for agriculture, and I love this example, and also as we will sense here the idea of enabling. So when I am talking to implementing computer vision application to help the farmers or the farmers to detect the diseases or anything inside the plants. So in this type, you need to have a tech person and AI expert to build this type of applications. But here, we enable the agriculture engineers or agriculture experts to build their models by themselves, as they are the domain expert. They know how to detect the diseases or how to make something like pest control and many things in the agriculture and the food fields that we as a technical person, we don't know this type of information, but they know. So as they know it, so they have the ability to build the best model for it through their knowledge in their field. And after giving the platforms or enabling them to build their systems by themselves, we have a totally different or higher accuracy models as it's fed or implemented by the human centering approach, not a data centering approach. And this is the idea of how to make it real products. The same also concept from agriculture to healthcare. So we have the same concept that by enabling the doctors and the medical experts to also make the models by themselves. So adding the knowledge or the medical knowledge in the loop. So we added a value to the model. So we have a higher accuracy and higher performance models. The same concept of agriculture we also apply in healthcare. With the same also methodology, we have many robots companies that already expert and powerful in robots system, but they are not expert enough in the vision system, and the vision component now is very important to build a mobile robot like this in this photo. So depending on tools to will accelerate the process of building algorithms to be implemented in this type of robots. So the same concept too in this sector. That by the way, this sector is very booming and very growing, and this is how the market is growing together between computer vision and the robotics system. And finally, we will go to the automotive sector, and we know now many big companies are going to develop many applications related to self-driving cars. And in this photo, you will see also how the camera above the autonomous car see the street. So it's a totally different view from the human view, and totally different about the object identification in the street through the camera. And all of that is dependent on the AI computer vision models behind the camera that make analysis and object detection for each object around the car on the street. So to build this type of complex models, yes, you need a powerful teams. In this case, you need a powerful teams, and for sure, the companies already have these teams. But why this case is different? As it is an intensive development case, so it needs a lot of time and effort. So besides also the expert teams, they need a tools like No-Code AutoML tool to accelerate their development process and to be as something like a faster prototyping and experimental tool for them. And there's a lot of operation inside the machine learning development operation itself need to automate it. For example, the labeling part that depending on the human. Now we see that a lot of auto labeling or auto annotation tools to auto annotate the images or the objects inside the images to be fed to the model to be trained. So this case is different, but just to show you, even if you have a very complex case like this and depending on a very powerful team, the team itself need to accelerate their process. So this type of tools. And now I will talk about the same concept, but from implementation side. So as we to implement any computer vision applications, the traditional one that we need to have cameras and with a stuff of lightning lenses and all that stuff according to, of course, according to the use case. But now, as we have our mobile phone with us, and also we have a good smartphone and a good computational power inside it. In the same time, we have a good internet connectivity, so we can also build many solutions on the cloud connected to the mobile too. We have a new perspective now. Is why we need to implement all this hardware stuff, but we have all the stuff inside our pocket in our mobile, for example. So now we have a new different way of implementation for system. We need to depend on our mobile phone, which already have a good cameras right now. Most of the mobile phone with us have a good cameras and also have a good computational power. And even if it isn't having this computational power or not enough for the application, you can make it through a cloud connection too. So it leads to main two items. The first one, make the implementation cheaper than before, so no need to buy all stuff of hardware. Second thing, makes the integration and usability easier. And this is the same concept of how to make the implementation easier. So we made it easier from the development side up through the no-code and the AutoML development, and also this way from the implementation side through depending on our mobile phone to run this type of application on production. So many applications now are shifting from using special hardware to using the commercial or mobile phone as a hardware tool with us and affordable for everyone. The second type of to have a different view of how to get benefits from the computer vision application. Why or how? It's through connecting it with the business management system inside the company or organization of the facility. So when you are talking about any computer vision system, so it will affect on the operation side. Okay, but now we have some systems, and by integration it with the management system, so we can automate the idea of task assigned. And this task assigned, it can be for a human worker or also for a robot. So as we have now the idea of connecting machine together, and that's one of the main aspects of Industry 4.0 methodology. So now we need to improve the business efficiency itself through this type of system. So we just first we improve the operation side. Second, we improve the management side. Third, we improve the business efficiency side. All of them are connected together. This opens the eye of the business to how to improve their efficiency by implementing this type of automation. The idea here, automation, the integration of the output from the computer vision system to be something like input to the task management system or the whole management system in the whole company. So it's a different view. It's the business perspective, but it's very important now as it's affecting on the decision making in many organizations. And now I will talk more about the AI computer vision models or tools. So these examples are more open source libraries, open source examples, so anyone can use it for commercial or for also research and development. We have different like AutoKeras, AutoCyclearn, H2O, and TTBOT. All of them are open source, so anyone can use them. So it is AutoML tools and libraries. And also, if you are focusing on the AI computer vision no-code tools, we have different tools or platforms appears on the scene now. Also, we have Tuba from DevisionX. We have Landing AI, RoboVision, Advise.io, and others. And all these platforms are available now for using, for anyone to use or want to develop a new AI model. I just will give a demo video from Tuba to just imagine how it works as an example. So just you now create your project. It can be labeling only or training or labeling and training or deployment. Now we will just start the training. You will just try to classification type of training. And now you can add the labels. Here we will use a class data set and add a class defect this one. We'll upload this data set, and after that the user will start the labeling part. Here in labeling, so you can just click on an image and just click on its defect, eye or shutter. After that, we can start the training. When you start the training, we have some configuration that can be done or can be done automatically, and after that he can view the training as a graphs to monitor it from his side. At the end, he can test the model, just upload an image and test it if it is shutter or eye as a defect. So it is very straightforward. Everything is happening on the background. Anyone can use it, and also modular. So here we see the enabling idea, so of building a new application and solving many problems based on this type of technology. Now I finished my presentation. This is my LinkedIn QR code and also Tuba QR code and my email, and I am welcome for any questions. Thank you.
Thank you, Mahmoud. Very, very interesting. And I wish that now the audience, the participants in this cafe, please send us questions. This would be exciting. I, of course, start. A dummy person in computer science, like a non-expert, can he really use your tools to make what you promise, like an application? I mean, can you be a doctor? Can you be a business person and have no computer science skills and you can do it, or do you need next to your computer scientist?
To answer the question, so yes, it can be done with a non-computer science to make the whole application from his side. And I can share with you another the example that I showed. So for this example, from the agriculture side, we have a use case now that we have agriculture company that wanted to just make a sorting for vegetables and fruits. So they have a different view. So they have some sorting stations, but they need to just take a samples and make a photos with a mobile, and the mobile gives them a decision if it's a good fruits or vegetables or have some type of defects, as example. So the person who built the model itself and built the application is non-expert. It's a pure agriculture engineer. So it's non-computer science. So the needed computer science is, for example, is to build the mobile app itself. So it's another topic to have the complete system working normally. But the person who worked on the system and built the model to make a differentiation or classification between good samples and bad samples is a pure agricultural engineer.
Okay. Okay, thank you. Emma, you want to ask a question?
Yes. Sorry. Do you like the AI ethical and legal politics in Europe?
Sorry, I didn't get the question.
The AI ethical and legal politics in Europe.
Do you like? I mean, you have to apply it. Do you like it? Do you have something to complain about it?
Yeah. Do you like them or not?
Yeah, I got the question. So first thing, that's to be compliant with the GDPR rules. So if you would provide it on the cloud, so we should be hosted on data centers or cloud providers based in Europe. This is a great thing, and have the whole security aspects on our cloud system. But from our side, we give it as an enabling tool for the user. So the user is still the owner of his data. He or she uploaded from his site to the system, and then it will generate the model. And also, as he the owner of his data, he also the owner of his model. The same sequence. And also, we can offer it as a on-prem tools or SDK. So if you have a sensitive data that you have a policies and you can't upload it on the cloud, we also offering it as a type of flexibility. We can implement the whole system in your local machines, so you can use it locally in your facility.
Okay, thank you. Here, maybe I know more than the participants. I am informed that you are an Egypt company, plus UK, and soon in Germany. You told me this, so this means like you are mainly in Europe. You want to have your customers. That's why also this question about the legal and ethical came up. I mean, do you like it? Do you not like it? The key is where and who are your main customers? Who are they? What kind of people are they?
Okay, so we have the main answer of this. Any organizations or company want to implement AI computer vision models or application inside their facility or their pipeline. The target sector right now is the robotics sector at the start. And second one is the automotive sector, especially the autonomous cars department or companies. And after that, system integrators and also manufacturing sector.
Okay. Now comes a question from the audience. Here it goes. Eugenio, what's the difference between Tuba AI and teachable machine from Google? Like, example, teachable machine with Google. You know the difference?
Yes, I know teachable machine from Google, and by the way, this is a good question. Teachable machine is it's something like experimental tool, so it is not at a production level. It have many limitations for the models development and deployment, and the main thing is that you don't have access to the model itself. You deploy it or you don't own the model that generated from your data, and also you don't have access to it. You just have access as an API, but not have access to it to download it or export it. So it's totally different in Tuba. So in Tuba, as you own your data, you own your model, you have access to download it, you have access to deploy it on our cloud, or also deploy it on your cloud, or deploy it on different other platforms, or on the edge, like NVIDIA Jetson boards or OpenVINO as example from Intel. So we offer a flexibility of deployment that you need, and also offer a different types of using Tuba. You can use it on cloud and also on-prem.
Okay, thank you. And now next question from the audience, from Panos. Can you give us an example of a low-code snippet? And how would that be converted to real code?
Okay, I will make it simple. I will take example from Tuba. This is what I know. So if you are a developer, I can call it not AI developer. You can be a web developer or mobile developer or any other software departments. And you need to implement a computer vision models in your pipeline. But as a developer, you don't have to work with a graphical interfaces. So we can offer you the SDKs behind Tuba interface itself. Then you can set up them locally on your machine, and then you just will work with a command line. This SDKs have documentation. You just will call some functions from it to develop your model, and after that the model will be generated through also the SDKs part. And we have different type of SDKs. So you can use the training part, the deployment also part to automate the model deployment for a Docker images. So we also have SDKs for this type. So it's not only also about the AutoML, it's also about the ML ops and how you have a running automated model on the production, on the server. Also, we have SDKs for this, and another SDKs for GPUs using optimizations, and finally for labeling part. So you will see that we have the whole pipeline SDKs. So instead of using the interface, you can use SDKs according to your preference.
Okay, thank you. Now comes Barnabas with basically two questions. What AutoML application do you suggest to use?
Okay, you mean AutoML tools, something like that. So I shared some tools here. So it is open source libraries. So if you aware of them and you are in the area of AI development, so you can use one of them. Actually, I can't recommend one of them as each one have its cons and pros, so it depends according to your experimental and your applications. But for sure, all these libraries or tools you need to have to be an AI expert to use them at the start. For this tools, this is a no-code tool. So also you need to try them first and check which is the easy one for you as a user, and also which one give you the flexibility of deployment and the highest performance, so you can choose it. Everything is experimental. You need to try, and I think all of them have something like a free trial. I don't know, I'm not sure, but most of them, for sure, in Tuba we have a free trial, so you can just sign up and they make this useful, and then you can decide if you need to continue or not.
Okay. Okay, I hope this answered the question. For me, yes. And now, Ahmed, now I realized that computer vision can be used in all different industries. Really great. I would say this is a compliment, not a question. So,
yeah,
I have
yes,
a question.
next.
I
You
have a
question. Emma.
You said before most customers are companies, but what about like students or like university? Is it also already like, do they already use it?
Yes, and here we have different types of users. So we have the computer science students and researchers. So also they can use this type of tools to accelerate their research. Maybe some guys will be anti this type as they are already a researcher, so you need to go deep in science to make it. But this type of tools can make some acceleration or at least the fast prototype for them to have a good research or to have a graduation project as example, something like that. So it is also one of the used or use cases. And I have another also interesting use case that the other students in the non-computer science faculty. So, for example, I know guys studying dentist, so the pure medical part, but they used to have a course in using AI in the dentist science, and they depend on one of the online tools to build their models as a no-code tools. So they are medical students, not computer science students, but they touch with this type of science. And this is, again, this is the meaning of democratizing this type of science.
Okay, so now Barnabas, now comes your second question. So the second question is, in your last example about business task separation, how do you involve the AutoML?
Okay, in this area, I will just give example to make it clear for you. You have a facility and you have a cameras monitor the performance in this facility. We can call it a warehouse, and so the camera and the computer vision system developed use AutoML make a monitorship or monitor for people inside it for forklift safety regulations and any other regulation in these facilities. And for example, we have something happens like a spot of oil, something like that happen. So the camera detecting it, and then we have alarm or alert that we have something bad here. We need to be removed. The integration is here. It's it's a normal system are ended by making alarm or alert for the in the facility to just make a warning signal to we have some errors here. But the complementing of this type of integration is to connect this output as an input task in the task management system inside the facility, so it can be assigned automatically to the responsible person to work around or to make a cleaning, for example, in this oil spot. And the second option, it can be a robot of cleaning. In some cities, they have their robots, so they can. It's a signal also to trigger this robot to make the cleaning stuff. So this is just just a simple example. So imagine what can be happen for the business management automation in this area.
Okay, thank you. And now the third question of Barnabas. He asked me to not forget the third question. And how many pictures can you add to train Tuba?
Okay, at the end, it depends on the use case, but to have a good accuracy in the classification part, it can be start from 50 images. In the detection and segmentation part, it should be like 100, so average 500 images.
Okay, so and then here comes a question. Maria asked, your system offers the back end, but how does the front end work?
No, if you see the demo video, you will see the front end. So we are offering both. If you use it as on the cloud, so you will sign up and log into your account, and you can use it as a front end, and everything is happening in the back end. And if you need to use only the back end part, so you need to license the SDKs.
Okay, and here comes another question from Barnabas, our most busy questioner. Could you please explain the optimal usage of Tuba, number of optimal training pictures, and confirmations to get optimal performance? So the best.
Yeah, it's a complex question, and again, at the end, everything as depending on the use case itself and the data itself. So we don't have a standard answer here, and there is no system have a standard answer for this question. But so this is why we, from the beginning, we called it an experimental development. And as it is an experimental development, it needs to be accelerated, and to be accelerated, it needs to be automated. This is the idea. The whole idea of this, why we need to acceleration and need to be automated, and we need to have this straightforward tools. So there is no standard answers, but as I answered this question before, for classification problems, it can be started by 50 images. For the detection and segmentation, it's 100 images, so it can be average 500 images.
Okay, and that leads to maybe the last question today, the limitation. I mean, Barnabas asked, does it have limitation about pictures?
So there's no limitation, I think, about the pictures itself. So you need to just have capturing it. So a picture can capture through cameras or mobile phone or anything like this. The limitation is depends also on the use case. So for example, the way you capture it, if there is a reflection, or if you have a lighting condition, there's some use cases need to have a special lighting, like infrared or other type of lighting. So again, it depends on the use case itself. But if you are talking about pictures or images, files, there's no limitation on it.
Okay, good. Then I think also Barnabas says thank you, and I say thank you. I think we have asked a lot of questions. Emma, you okay? Or you have another question? You okay? Good. So we are slowly coming to an end. And again, from us all, thank you that you're here, Mahmoud. And as you know, we will have the recording afterwards, send it to you. And if you think it's okay, then we as always, have it on YouTube. You just have to Google AI-Café YouTube, and there it is. Or you look on the project website, AI for Media. It's also fine. Okay, so I wish you all a good afternoon, and come back. Feel encouraged to come back.
Thank you very much for this. Yeah.
Thank you, Mahmoud,
you.
and have a nice afternoon, all the participants, wherever you're coming from. Bye-bye. Bye-bye.
Bye.
Bye-bye.